Welcome to the deep dive. Our mission today is, well, it's pretty technical, but absolutely crucial. We are diving deep into aircraft autopilot systems.
That's right.
And this isn't just about knowing which button to push. This is core stuff for your ATPL theory exams. We need to get into the definitions, the operations, really understand what's going on inside that box.
Exactly. Autopilots, I mean, they're fundamental to how we fly modern aircraft. And for the exams, you really need to grasp the architecture. We're talking basic stabilization right up to advanced flight management.
Yeah, what's happening behind the panel, how it all connects.
Precisely. How the system works, how it talks to the pilot, what happens when things don't work. That's the level of detail needed.
Okay, so let's start right at the beginning. The why. I mean, you've got highly trained pilots up front. Why hand control over to a machine? There are really two big reasons, aren't there?
There are. The first one is honestly pretty straightforward. Reducing pilot workload and fatigue.
Right. Flying, especially long haul, involves long periods of just holding an attitude.
Exactly. Tedious. Requires constant small corrections. Letting the autopilot handle that means the crew stays fresher, more alert for the really critical phases.
Like the approach, the landing, when you really need sharp focus.
Precisely. So it's a huge safety benefit, really, wrapped up in making the job less taxing.
And the second reason, it's about raw capability, isn't it?
It is. Performance. The autopilot can simply fly more accurately, more consistently than a human pilot over long periods, maintaining altitude, tracking a course. The precision is just better.
And faster, too. I remember reading about the reaction times.
Ah, yes, that's a key point, especially for the exams. Think about it. A human pilot spots a disturbance, figures out the correction, and starts moving the controls. That takes, what, about 200 milliseconds?
A fifth of a second. Sounds fast, but...
But the autopilot, it senses, computes, and initiates the correction in about 50 milliseconds.
Yeah, okay. 4 times faster.
4 times faster. And that speed translates directly into smoother flight, tighter tracking, better fuel efficiency. It just reacts to tiny deviations instantly.
Which explains why modern systems, especially when you pair them with autothrottle, can handle almost the entire flight.
Pretty much.
Yeah.
From shortly after takeoff right through to the approach. The pilot still does the takeoff manually, of course.
But engagement can happen quite low down.
Yeah, depending on the aircraft type and its certification, you might see engagement allowed around, say, 400 feet AGL, sometimes even lower on certain types.
Okay, so that speed and precision are key. Let's dig into how it actually achieves that, starting with the most basic function. If you strip everything else away, what's the absolute core job of any autopilot?
Auto stabilization. That's it. Just keeping the aircraft stable in pitch, roll, and sometimes yaw.
So all the fancy navigation modes, holding altitude, tracking a VOR, those are extras.
Exactly. They are built on top of the basic stability function. Think of it as the foundation. If the system can't keep the wings level and the nose steady, it's certainly not going to be able to navigate you anywhere accurately.
Right. And this core function, this auto stabilization, it goes by a few names in the textbooks, doesn't it? Important for ATPL questions.
It does. You'll see it called inner loop control, or sometimes just closed loop control, or simply auto stabilization. They all refer to the same fundamental process.
And its purpose isn't to give the aircraft stability it doesn't have.
No, not really. It's more about augmenting the aircraft's natural aerodynamic stability. An aircraft is designed to be inherently stable to some degree, but that stability changes with speed, altitude, weight, configuration.
Turbulence knocks it about.
Exactly. The inner loop works constantly to counteract those disturbances and smooth things out, fine-tuning the aircraft's natural tendencies. It keeps it flying precisely on the commanded attitude, whatever the conditions.
Okay. And understanding the sequence of how the inner loop does this, that's crucial exam knowledge, right? It mimics what a pilot does, just much faster.
That's a great way to think about it. It's a continuous 5-step cycle. First, it has to sense a change in attitude, a disturbance.
Like a wing dropping slightly.
Precisely. Second, it has to instantly compute what correction is needed.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best